Good afternoon. Today, we will be presenting biomechatronic signal sensing research. Our researchers are Orlando Alverio, García, and Lianne Sánchez. And this academic year, we will be working with Professor Nayda Santiago. Nearly 2 million of Americans suffer from limb loss due to vascular diseases or cancer, and not enough prosthetic limbs meet their needs. So what we're trying to do is, by brain signal sensing and characterization through an electroencephalogram, or better known as EEG, to do a brain control system. In this next slide, we can actually appreciate the global system view of our possible system. And it's important to notice that for this academic year, we will be focusing on the top 2 parts. So we will be focusing on collection of raw EEG data, sending that data through Bluetooth to a computer to do signal processing and system identification.
Hello, my name is García, and I'll be talking about OpenBCI, which is an open-source brain-computer interface, hence the BCI acronym. It can be used to read electrical brain activity, muscle movement, heart rate, depending on the modules that you pick for it. Because of its open-source nature, it provides you the STL files to building your own headset, and also specifications to building a board. The board that we chose is a Sight biosensing board. It has 8 channels and a 32-bit processor. It can sample data at 250 Hz with a 24-bit data resolution. It also can communicate via wireless RF radio and Bluetooth. The headset that we picked is the Ultra Cortex headset, which takes input from the electrical brain activity and transfers it to a board, in this case, the Sight biosensing board.
Hello, my name is Orlando, and I will be talking about pattern recognition, which is the system we will use to identify the signals coming from the OpenBCI. It will be partitioned in different components as shown in this diagram. The input will be the input signal received from the OpenBCI. Sensing component converts the input signal into a familiar signal we could manage. Segmentation separates the desired signal from the unwanted signal. Feature extraction measures properties of the signal we could use for the classification. The classification component, depending on the properties from the feature extraction, will give a category to the input signal. Then finally, the post-processing component will put depending on the category of the signal, it will give an action to the actuators so they could do a command. If you have any questions, you could contact us at these emails provided in the presentation. Thank you.